Hereby I open this academic ceremony in which Patricia Rosas will defend the academic thesis, The Role of Biomarkers of Hypercoagulability, Evaluating Thrombosis Risk and Outcomes in Cancer Patients. May I invite you to present a summary of your study and the conclusions of your thesis.
Thank you very much. Welcome all to my thesis presentation. This presentation is divided into 3 parts. The first one is the overview of hemostatic biomarkers and cancer. To understand the basis of this thesis, we need to delve into the concepts of hemostasis and thrombosis. Hemostasis is a well-balanced process that keeps the blood flowing, and it is part of a balance of all the coagulation proteins. This hemostasis is only activated when blood vessels are damaged. When it happens, a blood clot is formed, aiming to avoid bleeding. However, if there is a formation of clots, a pathological formation, this is called thrombosis. So it is very important to maintain a balance between all the coagulation proteins to avoid bleeding or thrombotic events. Cancer patients are characterized by an imbalance in these coagulation proteins. Indeed, cancer patients have an increased risk of venous thromboembolism. This venous thromboembolism is 4 to 7 times higher compared to patients who have not a cancer. The VTE incidence is around 4 to 20%, and the occurrence of an adverse event like a thrombosis is associated with a worse prognosis and a higher rate of antithrombotic therapy adverse events. Additionally, a thrombotic event is the second cause of cancer, death after cancer itself. Thrombosis, as you can see in this picture, thrombosis can be the peak of an iceberg. Thrombosis can be the first signal of the development of a cancer. This is because cancer patients are characterized by a hypercoagulable state during the development of cancer. So they have different grades of hemostatic system activation, and this continuous forming and removal of fibrin can help the tumor cell to grow, to metastasize, to invade, to have new neoangiogenesis. And all these hypercoagulable state can be measured by different biomarkers. Additionally, cancer patients, this hypercoagulable state is further aggravated by some clinical risk factors from the patients. So this thesis is based on the results of the HYPERCAN study. The HYPERCAN study is a prospective Italian multicenter study that aimed to measure different biomarkers of hypercoagulability, such as procoagulant proteins, anticoagulant proteins, markers of contact system activation, fibrinolysis, thrombin generation, and some inflammation biomarkers in 4 different cancer types. These cancer types are lung cancer, breast cancer, colorectal cancer, and gastric cancer. And we analyzed all the clinical and tumor characteristics of these patients. So our aim or our goal of this study was to, by these different biomarkers of hypercoagulability, develop some scores or risk assessment model to try to predict if there is a risk of developing a venous thromboembolism or another outcomes in cancer. Other outcomes in cancer could be cancer progression, cancer response to treatment, disease recurrence, or mortality. So by developing these kind of scores, our aim is to control this fibrin cycle, reduce mortality, ensuring treatment continuity, because all these patients can stop chemotherapy because of a complication due to a thrombotic event, or improving quality of life. So in the second part, we measured these biomarkers in relation to venous thromboembolism. We were able to develop 3 different papers about this risk in 3 different cancer populations. So these are the 3 cancer populations. The first one is the metastatic non-small cell lung cancer cohort. The second one is the metastatic breast cancer cohort. And the third one is a combination of locally advanced and metastatic patients with non-small cell lung cancer. So in all these populations, we measure different biomarkers like factor VIII, D-dimer, fibrinogen, prothrombin fragment 1+2, protein C, and free protein S. In addition, we measure thrombin generation. These are the parameters of thrombin generation: lag time, endogenous thrombin potential, time to peak, and thrombin generation peak. And in the third study, we measured specifically the complexes of contact and intrinsic system activation, such as kallikrein antithrombin, activated factor XI C1 inhibitor, activated factor XI antithrombin, activated factor IX antithrombin, and thrombin-antithrombin complexes. So in the first study, we developed a model, which was named the Lung HYPERCAN score. This score was based in 1 clinical marker and 1 biomarker. These biomarkers were measured in plasma, so the most predictive parameters in this case, in this cancer population that was only metastatic lung cancer patients, was D-dimer and ECOG performance. So by dividing this score in different thresholds, we were able to divide the population of having a risk of thrombosis in two risk groups. The low-risk group that had an incidence of a thrombotic event of 6% compared with the high-risk population that have a 25% of incidence of a venous thromboembolism. In the second study, we measured different hemostatic biomarkers at baseline to identify breast cancer patients that were at higher risk of venous thromboembolism during chemotherapy. In this case, we found that 2 biomarkers, one biomarker that it is a protein that is measured in cancer tissue. This is the Ki-67 index. This protein, together with fibrinogen, were the predictors of developing a VTE in this breast cancer population. So we developed also a risk assessment model based on these 2 proteins, and we follow patients, and after 1 year of follow-up, we demonstrated that patients that were in the low-risk group for having a VTE complication were in the low risk. 2.3% of, we had a 2.3% incidence of developing a VTE, and in the high-risk group, we had a 13% of incidence of developing a VTE. Finally, in the third study about the biomarkers measuring the prediction of venous thromboembolism, we measured the complete cohort of non-small cell lung cancer patients. These patients were the locally advanced cohort and the metastatic cohort together, and where our aim was to see if the contact system activation may contribute to the development of thrombosis in cancer. So we found in this case 2 biomarkers, the activated factor XI antithrombin and the thrombin-antithrombin complexes as the most predictive biomarkers for developing a VTE. So therefore, we develop a continuous score based on the beta coefficients of these 2 biomarkers. And in this case, we also have 2 risk groups. The low-risk group have a VTE incidence of 8%, and a mortality risk of 26% in the low risk, while in the high-risk group, we observed that the incidence of a thrombosis was 23%, and the mortality was of 41%. At the end, we also measured the biomarkers of hypercoagulability in relation to other cancer outcomes. We measured disease progression and disease recurrence in two different populations. So in the first one, we analyzed the population of non-small cell lung cancer patients in relation to disease progression. We measured two different kind of biomarkers, inflammatory biomarkers and hemostatic biomarkers, and we found a disease progression in the total cohort of 49%, mortality of 27%, and response to treatment, a complete response in 41% of the patients, partial response in 58%, and stable disease in 1%. So by analyzing all these biomarkers and all the clinical characteristics of the patients, we found that high sensitivity C-reactive protein and D-dimer were strongly associated with disease progression in non-small cell lung cancer. So we also developed a score that it is an easily useful score based on these two biomarkers that are widely used in the clinical practice. And by these two biomarkers, we were able to divide patients for a risk of disease progression into three groups: the low risk, the intermediate risk, and the high risk group. In the low risk group, we found an incidence of disease progression of 30%. In the intermediate group, we found an incidence of disease progression of 57%, and in the high risk group of 76%. So at the end, the second study for measuring other outcomes in cancer patients based on these biomarkers was the population of female patients having a high-risk breast cancer diagnosed who were already surgically resected. In total were 522 patients. And in this case, we measured thrombin generation by two different assays. We measured thrombin generation by the classical calibrated automated thrombogram, and we also measured this by an automated system that is called Genesia. So when we followed these patients after 3.4 years, 28 patients experienced an early disease recurrence, and we observed that patients who had higher levels of these markers of thrombin generation, the endogenous thrombin potential and the peak of thrombin generation had a higher risk of developing a disease recurrence. So you can see in these graphics that the blue line is representing the levels of the peak and the endogenous potential of thrombin generation, and in the first graph, you can see that patients who had a higher peak of thrombin generation experienced more disease recurrence compared to patients who had lesser peaks of thrombin generation. So we were able to divide three categories of risk in these patients, and between the low risk and the high risk, we had a difference of almost 15 times higher to develop a recurrence in these patients who had a high-risk breast cancer. In conclusion, this thesis suggests a new approach to cancer treatment by using hemostatic biomarkers and advanced models that assess different risks. These tools can predict not only venous thromboembolism, but other cancer outcomes such as disease recurrence, disease progression, and mortality. And this research helps to confirm that these scores that are accurate and easily to use are useful for the everyday clinical practice. And this supports a tailored approach to preventing thrombosis and improve personalized medicine. Thank you very much for your attention.
Thank you for your presentation. The opposition will be opened by Professor Beckers, Professor Internal Medicine and in particular Hematology at this university. Professor Beckers was also the chair of the assessment committee.
Thank you very much, Mr. Pro-Rector. Dear candidate, it was a real pleasure to start the opposition in discussing some aspects of your thesis. Before I do so, I would like to congratulate you and your supervisors on this excellent achievement. And being a hematologist involved in care of patients with bleeding disorders, it was really a pleasure reading your thesis. And not very surprisingly, my attention was especially drawn to chapter 7, in which you describe, a review is published as a book chapter, and you describe the multifactorial condition of thrombocytopenia and cancer patients. On the one hand, the risk for thrombosis, which is not less in these patients with low platelet counts, and on the other hand, the risk for bleeding by the same low platelet count. So it's something completely different as what you just told us. So thrombotic risk, I would like to focus on the bleeding risk in these patients. And you describe in the figure 66.4 the management of thrombocytopenia in these patients and on anti-thrombotic treatment. And I would like to focus on the bottom right corner of this figure, in which you state that some patients need antiplatelet drugs. So on the other hand, you have thrombocytopenia, which may cause bleeding, and these patients need antiplatelets drugs because of their medical history. And then it seems somewhat contradictory to this advice. Could you explain what is written in the bottom right corner?
Yes, thank you very much for your question, esteemed opponent. I talked very much about thrombosis during my presentation, and sometimes bleeding is a little bit forgotten, but it is also part of cancer patients. Cancer patients are also at a higher risk of bleeding events because we have this imbalance in coagulation proteins. It is very important to notice that patients, even if they are, most cancer patients have other clinical risks, such as age, for example, and most of them had other pathologies. In this case, in this figure, we describe patients who need any anticoagulant, who need any antiplatelet treatment during their lives, because these patients can be at risk, for example, for myocardial infarction, or they have a cardiac valve and they need to be anticoagulated. So what we try to do in this figure is to simplify the approach of these patients that are already under anticoagulants, but they had thrombocytopenia by different reasons during cancer. For example, chemotherapy can cause thrombocytopenia, or especially chemotherapy. There are other.
Sorry to interrupt you, but my specific point would be the discussion that these patients need platelet transfusion because they have a too low amount of platelets. So let's say lower than 20 or 10, so they need a platelet transfusion, and then they get, within an hour or at the same day, they get antiplatelet drugs, which irreversibly have a negative result on the donor platelets. So that seems somewhat contradictory. Do you agree?
It seems contradictory, but we need to have a balance in these patients. So
you're looking for balance, I understand. We do the same thing, but just wondering about the evidence for this advice. Or is it just consensus-based or expert opinion?
Most of these results are part of consensus because It is not established in guidelines, just only in guidance that are different of guidelines.
There are ISDH guidelines that are applicable to these cases. So, in my opinion, it's not very well investigated. And the next question would be, regarding all what you have just told us, the risk assessment models you have created to predict thrombosis or recurrent disease, can you envision or imagine some kind of scientific investigation in which you use the same models to predict bleeding?
Yes, other groups have already investigated this about the risk of bleeding, and yes, it is also very important to take into account bleeding.
So that would be another PhD then?
Yes.
Yeah. Okay. Thank you very much for your clear answers. I will hand over the floor back to the pro-rector.
Thank you.
Thank you. The opposition will be continued by Professor Kannegieter, Professor Clinical Epidemiology, in particular thrombosis and hemostasis at the Leiden University Medical Center. Professor Kannegieter was member of the assessment committee, and we highly appreciate your participation to this academic ceremony.
Thank you very much. So, dear candidates, I would also like to congratulate you with your very impressive work, also considering your diverse international background with apart from, you're from Mexico, you have a strong Italian component, and then you did everything in the Netherlands, so that's even more challenging. Nevertheless, you managed to produce, I think I just counted 6 risk assessment models. It's really a lot. So congratulations on that, and also for your supervising team. So I would like to discuss these models in a little bit more detail, and especially the implementation and the understanding of what's really in there. So, but before we start, can maybe one of your paranymphs read proposition number 10? Thank you.
The implementation of risk assessment models based on hemostatic biomarkers optimizes the risk stratification of cancer-associated thrombosis, thereby improving patient-specific care and ultimately leading to a better prognosis for cancer patients.
Thank you very much. Yeah, so that's, I think, the ultimate aim, right? That you want to improve the care for these patients, which is indeed very important. And my question is, so I understand that if you make a risk model to predict thrombosis, you can immediately use that to by giving trauma prophylaxis, and then you can actually prevent the event and do something useful for the patient. But how exactly do you envision to use these models for improving the care related to your other outcomes like mortality and disease progression? Can you explain a little bit about that?
Yes, this is because this hypercoagulable state or this fibrin formation during cancer also helps cancer to their development. So that is why we took this approach about measuring these hypercoagulable biomarkers for these reasons, to measure other outcomes such as disease progression and disease recurrence, because it is completely correlated, the coagulation proteins, with the development of cancer, the development of a metastasis, the development of neoangiogenesis. So that is why we use these biomarkers that are not usually used to predict mortality or to predict other outcomes for this reason.
Yeah, so it is the main reason then, if I understand you correctly, to understand better the mechanism, or is, I mean, can you also use this information to improve the care for these patients? That's basically my question.
Our objective, our goal is always to improve patient's life, quality of life. So when we measure this risk of developing, for example, a disease progression, we want to capture or to catch these patients that are at major risk of developing maybe with new chemotherapies or changing the treatment during the initial phase, for example, because we measure all these risk assessment models during the first months. So during the 3, 6, and 1 year months to see how they develop this progression. So what we want is to capture these patients that are at major risk and be able to change their management.
Yeah, so but then indeed by maybe changing to a new chemotherapy or
Exactly.
something like that. Yeah, okay, thank you. And related to that, so in chapters 2 and 3, you made 2 models, so one for the outcome of VTE and one for mortality. And the models are the same, so you find the same predictors that best predict those 2 risks. And for me, it's really difficult to understand why are they the same, because thrombosis is very different from mortality as an outcome. Do you have some thoughts about that? How you can explain that? I would expect maybe different predictors so that the predictors for VTE would be different from the predictors for mortality. Can you explain about that?
I think that this is because a venous thromboembolism is very related to mortality. Indeed, it is the second cause of mortality in cancer patients. So when we develop all these Cox regression analysis, they were the same, and we were able to use the same score because they were predicting the same.
Yeah, it's interesting, right? So then, do you think maybe that the VTE is the reason that they have a higher mortality, so that the cancer leads to VTE and that the VTE increases the mortality risk? Is that how you think it goes?
It is related. We only observed during our analysis that only, I don't remember in this moment, if 1 or 2 of the patients had a fatal event, a fatal pulmonary embolism, and most patients died because of cancer, not because of the VTE. No. But and that were the results that we found, that it is part of the cancer progression. All these measurements, all these biomarkers are part of the development of cancer. So maybe that is why it is related with mortality.
Yeah, interesting. There's still lots to do. Maybe just a final question, because now you made all these models, and there are already a lot of models around.
Yes.
So how is it, and do you have any ideas on how to make it easy for the clinicians? So if you want to indeed implement the models and make sure that they are being used, how will the clinician know which model to use in which situation? So for lung cancer, it's a different model from breast cancer, and even for metastatic lung cancer, it's again different, and then there are all the other models. So how would you help the clinicians to choose?
We have proved all the other models that are in use, like the Corona score, the Vienna CAT score, the CONCO score, that are the most useful in the practice or for all the researchers. All these papers about VTE in cancer always measure the Corona risk score. However, what we found is that some of these scores are not able to divide other cancer populations, specifically lung cancer patients. These scores are not useful. So we first measure the other scores first to develop ours. And the thing is that our scores need to be validated. In research, everything has to be validated to be used in the clinical practice. Before to be used, it needs to be performed by other researchers and see if it functions as it functions in our cohort.
Yeah, so you plan that should be done first before it's actually introduced in practice. Is that what you're saying? Yeah, okay.
Yes.
Thank you very much. I'm really happy with your answers. It clarified a lot, and I'd like to give the floor back to the prorector. Thank you.
Thank you. The opposition will be continued by Dr. Van Es, specialist vascular medicine at the Amsterdam University Medical Center. Dr. Van Nes was also a member of the assessment committee, and also for you, thank you for joining this academic ceremony.
Thank you very much. Dear candidates, also congratulations from my side with your beautiful work. Contributed a lot to the research and prediction of cancer-associated VT. And as you well know, most international guidelines, if not all international guidelines, now recommend or suggest thromboprophylaxis in ambulatory patients with cancer at high risk of VTE. So, at least in the Netherlands, these guidelines are not very much being uptaken in the clinical practice. I'm not sure how it is in Mexico or in Italy, but most oncologists do not follow these guidelines. So, from your perspective, what would be a number needed to treat that is low enough to justify thromboprophylaxis? What is your thought on this, based on your work and your experience?
What we observed, what we measured, is that at least 6% of patients need to be under risk to be like candidate for thromboprophylaxis. I don't have exactly the number needed to treat, but what we consider like needed for being under thromboprophylaxis is having an incidence of 6 to 10%.
6 to 10%.
6 to
So
10%.
all patients with a 6 to 10% risk of thromboprophylaxis, in your opinion, should receive thromboprophylaxis. Is that correct?
At least.
Yeah.
At least 10%, yes.
Okay, then my follow-up question is, in chapter 2, you followed a lung cancer cohort, and you showed that the overall incidence was 12% in that group in 6 months of follow-up. So why would we need risk assessment models at all if all the patients are actually already eligible for thromboprophylaxis based on their 12% risk?
Yes, that's a difficult question because these patients are also at risk of bleeding. So we need to improve these risk assessment models to know the patients that are at very high risk to be under thromboprophylaxis. So.
Yeah, okay, so to optimize the risk-benefit balance of thromboprophylaxis, highest risk of thrombosis and lowest risk of bleeding. Yeah, I can follow you. So, and I'd like to go to figure 2 on page 66 in chapter 2. And you showed some cumulative incidence curves for different risk assessment models in patients with cancer. And what caught my eye was in the right upper corner, the new Vienna-CAT score. And I hope you agree that in the high-risk group, the risk of venous thromboembolism in 6 months was about 16%, with a nice separation of the two curves. So to me, it looks like a perfect external validation of the Vienna-CAT score. So rather than going forward with HYPERCAN, which has not been externally validated yet as far as I know, why don't we proceed with the Vienna-CATs model? Because it is very easy, it contains tumor type and also D-dimer, which is included in your model. It can be applied to other tumor types. It also provides an individualized risk estimate. So shouldn't we proceed with the Vienna-CATs model?
Yes, of course, the Vienna-CAT score is good and it performed well in our cohort. So it is only based in one parameter, that it is the D-dimer and the type of cancer that, because different cancer types have different risk of VTE. So it is not the same, for example, for a breast cancer patient or a lung cancer patient, the risk of VTE. So the Vienna-CAT is a good and easily to use model. We wanted to see inside of our cohort which ones were the predictors of VTE, and we also had ECOG performance in these patients. So we developed this new score, even if the CATS, the Vienna CATS score function.
Yeah. Thank you. So for the last 2 minutes, I'd like to move on to chapter 3. And in chapter 3, you evaluated contact activation biomarkers, also in patients with lung cancer, and you evaluated complexes of antithrombin with factor 9, activated factor 11, activated factor 9, and kallikrein. So what is your favorite biomarker of the ones that you evaluated? Do you have a favorite? Quick answer.
This is like my favorite paper in.
Okay.
in
What is your favorite biomarker?
my favorite biomarker was activated factor 11.
Activated factor 11.
Because that was the predictor.
I thought you would say that. So I think my final question is: so why? So you were looking for contact activation pathway biomarkers. So why would you pick activated factor 11? Why didn't you use, for example, a complex of factor 12 with C1 esterase inhibitor? Because factor 11 is not only activated by the contact pathway, right?
The truth is that it was the easiest to measure. The other ones were more difficult to measure. And I think that it is important to know well this complex because of the development of new drugs that are based on factor 11. So
Professor Spronk has work to do to optimize the factor 12 C1 inhibitor assay. That's what I understand from your answer.
Yes.
Thank you very much for your answers, and I hand back the word to the prorector.
Thank you.
Thank you. The opposition will be continued by Dr. Calon, medical oncologist at the Maastricht University Medical Center.
Dear candidate, for me it was an joy reading your thesis, and congratulations to you, your family, and your supervisors. As a medical oncologist, I was drawn to chapter 4. If you look at your cohort, there's quite a high incidence of thrombotic events compared to what we know from breast cancer. I always say there's virtually no risk, but in your thesis, in your paper, you show a 7% risk. Do you know why this risk is so high in this population you investigated?
We think that it is because these are metastatic cancer patients, so metastasis can give us a higher risk of thrombosis, but we indeed observed that our incidence of thrombosis was higher compared to other papers, that it is around 2%, 1 to 2%, and we observed a higher risk, and maybe this is due to the awareness of during our study, during the development of the HYPERCOAGULABILITY study, because I think it's because of metastasis, because we didn't look for them like on purpose. These events were like symptomatic events and not were like, this was not a study where we look for the event. So we didn't measure exactly, for example, a Doppler or a tomography to look for it, to look for the event at some time. So I think it's because of metastasis and that's all.
Okay, so perhaps it's a bit more than we're used to having, so the real number might be higher. And I was looking at your table 2 and 3, in which I found that the Ka67 was a predictive marker for thrombotic events, but not for mortality. So the relationship between thrombotic events and mortality in this paper there was no real correlation. Do you have an explanation for that?
We try to measure this Ki-67 by two different ways, like the positivity, like dichotomic variable, or by the percentage as continuous variable, and we found that it was not predictive for mortality, even if it is a marker of progression of the disease or a higher with patients with an stage more advanced, for example. So in this case, it was not a predictor.
Okay. And if you look at the markers and you look at the breast cancer field, tumor infiltrating lymphocytes seem to be correlated more than TNM stage or any other marker. Have you thought about including them in your model?
To include, excuse me?
Tumor infiltrating lymphocytes.
We didn't measure like this. We measure leukocytes in the analysis, in the blood analysis, but we didn't measure specifically other lymphocytes or a tumor like liquid biopsy or something like that. We didn't measure.
No, you can measure them just by looking at the specimen by the pathologists, and the infiltration of the immune system is quite a strong predictive marker in the aggressiveness of cancer. I think it would have been a nice addition to the model. I think a last question on this chapter is, it's relatively a small portion of patients that you investigate. Do you think this is true evidence or more proof of concept that this can be done and that you need a larger cohort to evaluate the results?
No, we need to develop this or to validate these results in a larger cohort. Yeah. It is needed.
Yeah, thank you. Then I'd like to move on to the next chapter, chapter 5. And could I ask the paranyms to read up your proposition 1?
The close link between inflammation, coagulation, and cancer suggests that specific plasma biomarkers reflecting in vivo activation of hemostatic and inflammatory pathways can serve as valuable predictors of clinical outcomes, including thrombosis, disease progression, recurrence, and mortality.
Thank you. I really like this proposition, especially the inflammation part. What I saw in chapter 5 is that you measured high sensitivity CRP, but you're also an hematologist. I think if you look at inflammation, if you would look further, would there be pathways you'd check on more or less to look at what kind of inflammation it is? Have you thought about that concept of inflammation?
The concept is that inflammation and cancer development, thrombosis, hypercoagulability, it's completely correlated. So if we saw one pathway, we can have a mirror with the other pathway, and that in this case is the inflammatory pathway. So that is why we measure these two different pathways to know if they have a common outcome.
Yeah. Do you think that matters which kind of cells are activated that cause the inflammation?
I didn't understand the question.
So what kind of immune cell activation do you have that causes the inflammation itself? Do you think that would matter?
Yes, it is part of the cancer development, so this immune response. So So yes, I think we are showing that
No.
the immune system. Sorry.
No problem. Thank you for your answers. I'd like to give back to the corrector.
Thank you. The opposition will be continued by Dr. Nagy, researcher at the Karim Research Institute at this university.
Thank you. First of all, dear candidate, I would like to congratulate you and your supervisory team on this nice work, which I read with high interest because biomarkers are quite a little baby for me. And your thesis, I think, represents a very comprehensive work because you really focused on well-defined cohorts and you really looked into multiple angles. And while reading your thesis, actually, some question came to my mind, and then I would like to focus on mainly chapter 2 and chapter 3. In chapter 2, you used thrombin generation with 5 picomolar tissue factor trigger. And you found that this was actually as independent risk factor with a univariate analysis, but it got lost during multivariate analysis. And then when we look at chapter 3, there you identified contact activation as one of the possible leading cause. Do you think if you would have known the results of chapter 3 before chapter 2, and would you have changed the trigger for thrombin generation to make it more sensitive for contact activation? Or would that change your outcome?
Yes, maybe this is something that we didn't measure, but yes, if we think like this by changing our results for the 3rd chapter, yes, it could be a possibility to develop this thrombin generation with other triggers to see if it can function, because yes, thrombin generation, even if we have some good results, it get lost during the analysis.
Yeah, but of course after new studies we are always smarter. But indeed, and in chapter 3, you also indicated as a result that kallikrein showed a stronger positive correlation with factor 11C1 inhibitor and factor 980 complexes in patients with VTE compared to the ones who were VTE free. Have you actually looked at also the inflammatory state, or have you correlated this with the inflammatory state of these patients? Because we know that inflammation also can, well, one of the leading causes behind VTE.
Yes. When we measured this C1 inhibitor, what we observed is that it was not as performative as the other one, as the inhibited by antithrombin. So at the beginning, it was part of the predictors, but when we developed the multivariable analysis, it remains out. And even if the C1 inhibitor is the strongest inhibitor of the pathway of the activated factor 11, it was not. But I think it is a statistical result.
Yes, that's indeed. But I was more wondering whether, because the PK effect, it can also come from, of course, inflammation, because factor 12 is a bit of a mystery protein always, because it's depending on the trigger, can go towards inflammation or more coagulation. So that's why I was wondering whether have you actually correlated your coagulation data in this cohort to inflammatory markers?
Yes, in this case, we also measure all the different biomarkers, except for C-reactive protein. We didn't measure it here, but yes, by correlating them, they remain as the only biomarkers or the strongest one.
Mm-hmm. And a bit following up on what already was mentioned in previous discussion regarding, because you mentioned also that the outcome of chapter 3 is main interest for the novel inhibitors. And seeing that recently these factor 11 inhibitors showed some failure in certain trials, do you still think that it could be useful for this patient population?
Yes, even if it is like very difficult to measure them, I think it can be useful.
And then if you if we go back again to chapter 2, where you showed that already the antiplatelet therapies actually seem to be preventive against VTE, although you really precautiously mentioned that it was not the aim, so we have to be more cautious about the outcome. Would you, if you could choose, would you focus on novel inhibitors, like for instance factor 11 inhibitor, or on the existing antiplatelet therapy in the patient to prevent VTE?
No, as a clinician, I think that we have to use anticoagulants, and maybe I will focus on inhibitors of factor 11 and on antiplatelets, even if it was like a protector in our results. This is, for me, this is just part of the statistical analysis, but in the clinical practice, it is not useful. Patients bleed much more with antiplatelet treatment than with anticoagulant, or they have different risk or different mechanisms.
Yeah, thank you for your answers, and I would like to give back the word to the prorector.
Thank you. The opposition will now be continued by Dr. van der Meijden, researcher also at the Karim Research Institute of Maastricht University. Dr. van der Meijden is also the secretary of this degree committee.
Thank you, dear candidate. Congratulations also from my side. It's a beautiful thesis. I want to congratulate you and your team on this major achievement. You've published all the work, so all the chapters, so you can be really proud. I started reading your thesis, chapter 1, the introduction. I enjoyed it very much. You provide an extensive overview on the mechanisms behind the increased thrombosis risk in the cancer patients. You mentioned also cellular interactions that they contribute to the hypercoagulable state. So tumor cells can interact with platelets, leukocytes, other cells. There are many interactions between blood cells, but what strikes me is that you measure plasma biomarkers, so you do not take into account the cells. So don't you think you missed this major components of cells in your analysis and in accurate risk prediction? What do you think about that?
Thank you very much for your observation. Yes, it is very important to measure other interactions, like cell-cell interaction, endothelial cells interactions, platelet interactions. But in this case, because of the nature of the HYPERCOAGULABILITY study, that was a multi-center study, that was like, it is not easy to have so much patients in different parts of the country. So measure plasma biomarkers is easier because you can freeze them, you can measure them in other times and not at the moment, and measuring endothelial cells or other markers, even if it is very important because they are part of the mechanisms, it is more difficult to measure, to handle with every...
Yeah, so in terms of logistics, I understand that this is much easier, but if you had the opportunity to do it again, and if logistics is not a problem, how would you approach it? What would you measure in addition to the plasma biomarkers?
I think I would like to measure endothelial cells.
Why?
For me, I think so. I am not sure, but I think that it is easier to manage them. I also observed some works in your laboratory in this place from platelet, these chambers, like in vivo platelet activation and etc. And I don't know how difficult it is to measure that, but I don't have any experience doing it or managing other cells. That is why I am telling endothelial cells.
Okay. We also know that tumors can communicate with other cells via extracellular vesicles. So they can communicate with platelets, they can bind to platelets, activate the platelets. What is your opinion on the diagnostic value of these extracellular vesicles? On the one hand, maybe, but maybe also on the other hand, the diagnostic value of platelets. Would that be an option to use in the future?
Yes,
in
and
risk prediction?
yes, these microvesicles are something that is already under study, and some studies have been developed with these measurements, and they play an important role because they can carry tissue factor, and that is the main activator of coagulation. So yes, it is they play an important role in this risk. So it is very important to measure them.
So do you think the extracellular vesicles are present in your plasma samples? Are they still in there?
Yes, but at the beginning we didn't perform all the centrifugation that is needed to have these microvesicles, and maybe they are there, but
yeah, I think you use a relatively low speed, so I think they're still in the plasma, so it might be also a very useful source to measure a cellular origin or whatsoever. It can be useful in risk prediction, I think. Yeah.
Yes, thank you for your observation.
Yeah. One other question. In your thesis, you state that the risk of VTE is not constant throughout the disease. It is most pronounced during the first few months after cancer diagnosis, especially following the initiation of chemotherapy. But in the presented studies, so chapter 2, 3, and 4, blood was collected prior to chemotherapy. So if you aim to identify cancer patients at higher risk of VTE during therapy, then why don't you collect the blood during the treatment? And why do you collect it before treatment and try to predict the risk of VTE?
During the HYPERCOAGULABILITY study, there was collected also plasma samples during the treatment. So my results are only based on the basal analysis, before they started chemotherapy, but we measured these samples also at 3 months, at 6 months, at the end of the chemotherapy treatment. We don't have these results now, but they were measured.
Okay, so because coagulation activation can also evolve, right? During treatment, it can change, and thereby the risk of VTE can change probably. So what would you expect? Would you include multiple measurements in the future if you kind of implement this system, this biomarker testing in your daily practice? Would you choose to use multiple time points and measure biomarkers at these multiple time points, or what would you do?
Using different time points could be interest to see if these risks remain during the treatment, if these biomarkers change, and if these scores are useful only at the beginning of the treatment and not after the beginning. Because if we measure these biomarkers at baseline and are not representative after 1 year or after, I don't know, 6 months of beginning chemotherapy, maybe at that point our score is not useful, will not be useful. So yes, it would be interesting to see how these biomarkers change during the time.
Yeah, definitely interesting, I think.
Yes.
Yeah. What do you think is the effect of chemotherapy on the coagulation activation biomarkers that you've measured?
Inflammation, because it is involved in inflammation, and also cell death cell. So all these cell death, platelet death can active coagulation.
So you expect higher D-dimer levels, for example, or
You can shortly answer when you prefer.
higher D-dimer levels during therapy? Do you think that is observed, or?
Yes, they play a role because chemotherapy is a toxic, so during cell death, it is activated also coagulation, so it is part of the mechanisms.
Thank you for your answers.
Thank you.
Patricia Gomez Rosas, the time appointed for defending your thesis has passed. The degree committee will now withdraw to discuss the quality of your thesis and your defense. I request that you and your company await the results of our deliberations and now return to this room. Patricia Gomez Rosas, the degree committee here present has assessed the quality of your thesis and your defense in view of its positive verdict and taken into account your previous qualifications. The degree committee has decided to grant you the degree of doctor. Professor Spronk is authorized to confirm upon you this academic distinction in accordance with Dutch university custom. I invite your supervisor to now take the floor.
Please, all rise.
Thank you, Mr. Prorector. Do you promise to work in accordance with the principles of scientific integrity at all times, to be careful and honest, transparent, independent, and responsible?
I promise.
Thank you. By the authority vested in us by law and in conformity with the decision of the committee here present, I hereby confer upon you, Patricia Gomez Rosas, the degree of doctor and grant you all the rights attached by the custom and law. As evidence of this, I now present you with the degree certificate signed by the rector, the secretary, and the other members of the committee and affixed with the official seal of the university. Dr. Gomez Rosas, congratulations personally on behalf of the team. Very much well done. Maybe you can translate for me to your relatives, to your mother, because my Spanish is not so good. So congratulations also to your mother. You may translate, because you will say it in Spanish to your mother.
Me felicita y también te felicita a ti por el doctorado.
And welcome in this beautiful town, Maastricht. The laudatio will be spoken by Dr. Marchetti, so I hand over the microphone to Marina.
Distinguished members of the committee, colleagues, friends, and family, it is a profound honor to deliver this laudatio for Patricia Gomez Rosas. Today, we celebrate a researcher who has faced every challenge with dedication, intuition, and a rare sensitivity. Patricia's journey with us began with a defined moment of initiative. Having met Professor Falanga during the European and Mediterranean League against thrombotic diseases in Venice in 2018, Patricia expressed a precise and determined desire to join our research group. Professor Falanga immediately recognized Patricia's seriousness and extraordinary potential, so much so that she moved even and earth to ensure Patricia could join our team. That mutual recognition was the foundation of a path defined by clarity of purpose. A researcher journey continued through the long-standing, decade-long collaboration between our group and Professor Hugo Tenkate and Professor Ernst Brock at Maastricht University. This international synergies was instrumental in shaping her work, providing a world-class environment that has ultimately led her to the successful discussion of this doctoral thesis today. Her thesis, The Role of Biomarkers of Hypercoagulability, addresses a critical frontier in oncology. But for Patricia, science has never been just a cold analysis of data. She possesses the eye of an artist, an essential trait for what I called the alchemical process of research. She transforms raw data into insight, finding patterns within the chaos and infusing her work with the creativity that drives true progress. This dedication was tested during the lockdown, when Patricia and Eleonora became a constant, tireless presence in our coagulation laboratory. They dedicated themselves without interruption to investigating the causes of thrombosis in COVID patients. In those silent months, Patricia's art became a form of courage, placing her research at the service of human life when it was needed most. However, Patricia's resilience has also been tested in more surreal ways. Who could forget that night searching for a kitten, Calypso, across every corner of the city? After hours of agonizing search, the breakthrough came in the absolute silence of the middle of the night. It was only that the Patricia heard a faint meow coming from the most unthinkable place, literally inside a hole in the wall of her own home. Finding her alive was a miracle of persistence, and a lesson that sometimes the most complex solutions are hidden right where we least expect to look. The beauty of these years lies in the bonds she built. The best part of her research often came at the end of the day, when together with Deborah and Marco, the tension dissolved over a glass of excellent Sicilian by Amore wine and good prosciutto and mozzarella. In those moments, we saw the heart of our group, a journey nourished by friendship and a shared beauty. Patricia, you have proven to be a scientist, an artist, and a resilient spirit. You handled a global pandemic, international high-level collaboration, the complexity of biomarkers, and even the daring escapes of a kitten within the same race. It is with deep pride that I officially welcome you into the community of PhDs. Congratulations, Dr. Gomez Rosas.
Dear Dr. Gomez Rosas, it's a pleasure also for me on behalf of the Maastricht University and the Board of Deans to congratulate you with this new degree you just acquired, and the university wish you all success in your future scientific and clinical career. I also will extend my congratulations to the supervisors of your PhD journey, and of course I will also include your family with this, to congratulate them with this special day today. So I will, before congratulating the new doctor, we will make a picture on the stairs in the central hall, and also probably with your mother, and hereby I will close this academic ceremony.